Hello everyone and welcome back to Capacity TV here on the networking terrace at Datacloud Global Congress 2026. I'm Amber Jackson and I have the privilege of being joined by Matt Coffel, Chief Commercial and Innovation Officer at Mission Critical Group. Matt, it's lovely to see you. Thank you so much for taking the time.
Great to be here with you, Amber.
And Matt, you've got some big news to share at Cannes this week. MCG recently unified its brands under one identity. I wonder if you can share what this rebrand represents in your company's evolution.
Yeah, it's a big accomplishment milestone in the evolution of MCG as a business. MCG was never designed to be a group of brands or a company of companies as a power system solution company. Really, the architecture of the business was to deliver integrated power solutions to the end market, to the consumer. And having multiple brands is a disjointed way to try to accomplish that, right? So a unified brand ultimately not only provides common identity to the customer, but internally, we've grown substantially through acquisition, but our revenue composition's probably 70-30 organic versus acquisition. So as a business, our strategy really is to acquire great businesses because of capability, geography, product, specialization, and then bring it into, the overall MCG offering, right? Which at the end of the day, we really specialize in delivering from secondary side of the substation to rack level power. And that's a solution delivery to the market. So as one brand, it makes that a lot smoother of a, customer experience. It's a lot smoother for our internal teams, right, to be part of one team versus siloed. And actually, when you look at our investment in innovation, our investment in capacity, that accelerates a lot with having one identity versus some investment here, some investment there. So we're very excited about it. It's a big undertaking. Our marketing and internal teams really have a heavy lift that they've gone through to accomplish it.
Well, I mean, you've certainly got no shortage of things going on at the moment. Obviously, your manufacturing footprint in the US has grown significantly. You've recently acquired TXLA Systems, and then you've got another manufacturing facility in Pennsylvania. Why is expanding that capacity so important for your strategy?
To increase our ability to deliver within a region, number one. So if you were to look at our manufacturing footprint, it's very strategically placed around where customer demand happens to be for data center and on-site power generation. Clearly Texas running across the Southeast into the Mid-Atlantic is a huge area of demand. So the closer we are to our customer, the better ability to deliver. We have to expand capacity to support the demand at hand. It's also an investment in being able to support additional demand down the line. So as we open up new facilities, we'll eventually grow those facilities to having multiple shifts, which enables us to shorten, time to power for customers, which is really the name of the game in our industry right now. A lot of this expansion, though, on Pennsylvania in particular, is really about expanding our switchgear and switchboard manufacturing capacity. Pennsylvania is a real hotbed for that, and it's very close to Northern Virginia, which is clearly, the largest data center market in the U.S. Our acquisition of TXLA really is around twofold. It's expansion of switchgear and switchboard capacity. Also, a very high amount of flow good manufacturing capability, like relay panels, bypasses, etc. But they have a very, very strong modular fabrication footprint in Texas, which Texas is the other big data center footprint area of growth in the U.S. right now.
Fantastic, and yeah, as you said about the data center market at the moment, it's fast paced, it's complex. What challenges are customers facing today, specifically around power infrastructure and speed to market?
Oh, there's a ton, but I mean, it really starts with power availability. These are complex projects based upon the scale. Um, all of the user base needs everything the day before yesterday, and you have a real shortage of utility interconnection. It's taking a lot longer for utilities to deliver, which is driving the behind the meter, power generation space. The challenge with that again is behind the meter projects are complex. Large volumes of turbines are not something that are quick to install. So customers are having to use portable, solutions as bridging. Um, you know, you need a lot of switch gear. You need a lot of modular components to actually integrate uh, these on-site generation sources, and things just can't happen fast enough. There's a lot of resistance in certain communities, maybe due to a lack of full awareness of impacts of data centers. So there's a lot of work that the developers have to do to work with local communities to actually achieve the speeds that they want to. And then, there's just a ton of compression upon supply chain. So we're back into it's not anywhere near what it was during COVID, but lead times are definitely growing on components. So from our perspective, we're taking a very proactive stance on stocking programs on the components that we need so that we can continue to improve lead times on our delivery. But it's really a complex formula to build a large data center, regardless of how, let's say, offsite constructed it may be. The scale of what's being built, there's only so far that you can compress these schedules. And I think the biggest thing, which regardless of how much we can manufacture and really turn construction into more of assembly of data centers on site, still a really severe shortage. And this isn't just in the US, but from talking to customers here in Europe, the skilled trades, uh, and by skilled trades, actually really highly qualified tradespeople that it takes to interconnect and to, do these installations on site. That's probably the longest pole in the tent in terms of if you have power availability, the labor shortage is really the big challenge. So the more that these projects can get shifted to factories, the more can be automated. It's a lot easier to automate, in a factory than construction in the field. But I mean, those are really the two challenges. It's getting power delivered and then the actual labor that it takes to build. That I think are the big things that we're trying to overcome. So, with a focus on prefab, the goal is to be able to parallel path. We're manufacturing a lot of modular power systems that can then be integrated on site while the site works are being done. So it shortens the overall delivery time.
Sure. And I wonder if I can get your kind of insights into why the industry is moving towards 800 VDC architectures for AI factories and those next generation data centers that you've been talking about.
Yeah, so there's a definite crossroads ahead of us. The densities that we're seeing in compute are astronomical compared to what they were not even 5 years ago. Um, when you see people who've been in the industry a long time, they remember 10 kilowatts in a compute rack being a lot, unless you were talking about a university or research facility. We're delivering projects where customers have 200 kilowatts in a individual cabinet. And if you look at some of the chip manufacturers' roadmaps, within 2 years ish, you'll start seeing tripling of that density on a per rack basis. So to effectively deliver um, that volume of power density, and when you really think 600 kilowatts in a rack, in the cloud world, that's not necessarily the case. I think it's important to think, there's a crossroads, what cloud needs versus what AI factories need, clear differentiation. These ultra density racks are for GPU deployments, and where these high density deliveries get to, there's just no way to power these cabinets without going to DC and with like direct fed DC to hit those densities. It's a overcoming physics matter. Um, And ultimately, we're very focused in that space to be a leader. We've made a core investment in solid state transformer technology, where we'll be delivering, integrated SST configurations up to 6 megawatts. So ultimately, you can put in a single module with batteries close coupled and the DC switchgear, shrinks footprint, increases reliability, frankly, because a lot of the issues with the GPU chips that the industry's been facing create it's driven by a lot of transients in the power. DC distribution and DC power conversion smooths a lot of those load profile issues out, and actually allows that density to be delivered. So on our roadmap, we're delivering SSTs in 26 in a couple of customer implementations, and we're looking at the high density delivery in the latter part of 27.
Fantastic. And could you speak a little bit more about how MCG is able to support that shift? And then I suppose kind of more big picture, where do you see the biggest opportunities for innovation and growth for the company moving forward?
Yeah, so MCG, I think, is uniquely positioned because of a lot of the team members that we have are very experienced across the spectrum, from a technical perspective in the power system space. We've had some unique talent. People have a lot of experience in the DC realm. We're already on staff, either because they had background in microgrids, they had background in subsea work, they had background in telecom. So we have a big, basis of experience in the DC space, as well as some folks that were industry leaders in the battery energy storage space, which is a big part of these DC solutions. So I think we're uniquely positioned, and then we have a very strong partner on the core technology, the actual power electronics, that really have a leading technology. It was actually developed for a different vertical, different market focus than data center. We're porting it over and then doing the actual SST and module manufacturing and battery integration in our facilities. We have the right manufacturing footprint, the right locations, the right experience from a leadership and engineering perspective to deliver these solutions, and then the right partner. Now, when we look at our innovation roadmap, a lot of this is productization around more medium voltage, because we think medium voltage, will continue to be it's a real big change in the data center space, just because of the densities and the amount of power being delivered. So we're very focused in that area. We're very focused in productization of the power backbone modules that we're building now. And then I think, some other things that we're looking at are materials technologies, both from a structural perspective, are there better, faster ways, than this type steel structures that we're using, that we're considering. We're also looking at things like cable distribution. Are there ways that lower weight, lower cost, increase safety, through different, power distribution technologies within, the systems that we're deploying. So, it's a really exciting time. There's a lot of opportunity at hand, and I never thought, that we'd be seeing little compute densities in a single rack that are equal to a data hall that was being deployed 10 years ago. I mean, when you think about it on that scale, it's mind-blowing. So I think the amount of engineering challenge at hand is really hasn't been this way in data center probably since really, the cloud started launching, at scale about 15 years ago.
Well, I mean, it definitely sounds like a great time for MCG. So, Matt, thank you so much for your time and talking to me in the sunshine.
Pleasure to be here. Thank you for your time, Amber.